So let's go ahead and take a look at the options for managing and manipulating data in Grasshopper. The next thing we want to do is take a look at those data matching options that we looked at in the slides. Right? So one thing that we frequently find ourselves doing is working with a primitive geometry, such as a polygon. And if we take that polygon and we take a look at the parts of it, right? If we go ahead and explode that, we're going to get a series of segments and vertices. Now, because this is a closed polyline or a periodic curve, the start and end point are repeated whenever we gather the vertices from the explode. But we also know that the segments we only have 6. So in this case, our hexagon gives us the 6 segments around the edge, but 7 points because the start and end are both included. So frequently what we want to do is, let's say, build some geometry at each one of these points. So if I dropped a circle into the definition and said these vertices are going to be located here, these vertices are going to define the center of the circle. Let's say I grab a slider to define the radius, so I have a little bit more control there. All right, so now these circles are at each one of these points. Now, I actually can't see that, but if I look at the data, I know that I have 7 circles present. So I want to get rid of the extra, because when I go to let's say, do some additional work with these circles, connect them or something like that, I'm going to have a duplicate that I'm going to have to contend with. So one easy way to essentially remove the duplicate in this condition would be to use those data matching objects, specifically the shortest list, so that we can say, well, we have 6 segments, we have 7 vertices. Trim the end of the vertices, so now I only have 6. Right? It doesn't look that much different here, but if I were to continue building my file, I'd realize that I'd have a lot cleaner set of circles without any overlapping geometry, etc. So that's just using the shortest list. And you can do the opposite of this too. If you had, let's say, 1 circle and 6 segment midpoints, I could duplicate the circles so that they would correspond with the segment midpoints by using the longest list. And last, let's take a look at the cross-reference. Right? I'm going to go ahead and turn the preview off of all of these guys here. And what I want to do here is say that all of the points that defined the hexagon, I want to connect them all. Right? So cross-reference gives us all possible combinations of 2 sets of inputs. So if I take those 6 points that I found here and put them into both A and B, this would allow me to connect them with a simple line where all combinations are found. So what it's doing is it's duplicating my 6 points in a sequence so that all combinations are found between them. Right? So this also has duplicates. Let's say point number 1 finds point number 2, and vice versa, 2 finds 1. So it's not necessarily an intelligent way to go about doing it, but it will make all those possible combinations. And the last option we want to take a look at in relative to the list and tree objects that we've highlighted for what's new in Grasshopper version 9 are the sift and replace null objects. Now, both of these objects are found here, and we're going to use them in combination. So here's our sift, and here's our replace nulls. Let's take a look at the sift. Let's say that we want to, from our panel that we drop into the definition, we want to sift a collection of items. If we double click the panel, let's use kind of location, like cities, right? So New York, London, Barcelona, and Sydney. All right, I make sure that this is set to multi-line data off. Now I have a list of cities, and I can use I can use a pattern to sift them into two corresponding lists afterwards. So I'll copy and paste this and drop in the right and the left side of the list from 0 and 1. And I'll also copy and paste it so I can define my own pattern. Right? So this says sifted into the two lists based on the pattern that I put here. Now if I zoom in, this is also relatively new to Grasshopper. You have to zoom in on some objects in order to access the more dynamic qualities to them, where we can insert output parameters so that we now have a to option, right? And we could say, okay, well, we actually want to put them onto three lists, 0, 1, and 2. All right, zoom in and we can remove that as well. Put that back to 1. All right, so now we can see that we can put these into two lists based on this kind of sorting rule. 0, then 1, then 1. But we also realize that we're getting nulls here, right? So London and Barcelona, which both are in Europe, just so happen to fall into this list. So let's run with that. Let's say that we want to add, for every one of these empty slots here, a new item. So I'm going to use that replace nulls object, which is under sets list, replace nulls, and say the output 1 here is going to go into I, and R is going to be what I replace it with. So I'll copy and paste my panel once again, and I'll say that use another European city like Berlin, and replace every null with Berlin. So now if I look at the resulting list here, it's going to say Berlin, London, Barcelona, Berlin. All right? Now, this is a kind of textual example, but the same would go for if we're calling geometry out of our definition, and we might want to go ahead and put new geometry wherever the pre-existing geometry was before. All right, so let's go ahead and make a new Grasshopper document. And here what we're going to do is we're going to start by taking a look at a way to visualize the data paths that are corresponding to a collection of items that are in a data tree, and show that in the Rhino viewport. This is going to take advantage of some of those new objects we were just taking a look at. So first things first, a way to get some quick geometry that is organized in data tree is to go ahead and drop in the square grid object, and you can go ahead and use a triangular grid if you want, or another type of grid. The square one's really the easiest to get started with. So what we're going to do is we're going to take a look at what's coming out of the outputs of this object. Coming out of P, we have all of the points that are at the corner of the grid. And out of C, we have the actual rectangles. Now, notice that either one of those, they're both organized in a data tree. So if we're looking at the points of our 5x5 grid, we actually have 6 points in either direction. So we have 6 lists of 6 items. So we can see that in the panel. We can also look at that in the param viewer. Right? But in either case, it's limited in terms of what we see and what we can then do to the data afterwards. If I use the data coming out of the panel here, it is that representation of those points. If I use the data coming out of the param viewer, it is the representation of those paths on one big long list. I can't access this additional information, so that's where the tree statistics object comes in. If we go ahead and drop this in, which is here under the sets tree tab, tree statistics, instead of just the individual elements coming out of here as the paths themselves, we can gather that list, but we can also find out how many items are on each branch, as well as how many branches there are. So you can start to craft your data trees with this object because of the additional information you have to work with. So let's say that we want at each one of these point locations to show the corresponding path. Well, for starters, to make things a little bit easier, let's go ahead and right-click the P input and say that we're going to simplify it. This gets rid of those extra zeros that are hanging out in the data paths. So now we have a simplified set of paths. And if we then graft that same output by right-clicking, we have a unique path for every item, right? So we can gather that information here, the strings that are coming out of the tree statistics, or we can take a look at it in the tree, the param viewer. So now I want that information to be located at each point. Now the issue here is that if we notice coming out of our grid, we have a double dashed line. That's our indication that we're working with a data tree. Coming out of here, we have a single list. So we have to match these up. Now, previously this was, you could either flatten or graphed, I guess, but the match tree object allows us to do that without really having to think about it. If we go ahead and drop in that object from the Sets Tree tab, it's here under Match Tree. It asks for the tree to modify. Well, that's our list. And the data tree to match, that's going to come from here. Now this is going to turn red. I'm going to delete this, get out of the way. Zoom in here. This is going to turn red because the input trees must have an equal number of paths. So all we need to do here is graft our tree statistics. And now this set of elements, right, this data, which is our paths, is now organized in the exact same way as our points are. So we can go ahead and go into the Vector tab and grab a text tag and label this text at that location. So we can now see each one of these elements here as text in the viewport. All right? So now we can see the actual path that corresponds with that point. Super easy and really a great way to get up and running with visualizing what you're seeing from your geometry relative to its data structure inside the Rhino viewport. And this match tree object can do far more than that. And this is just a quick example of how to get that up and running.